Welcome to another lecture on complex variables and transforms, and we are studying Laplace transforms. And in this lecture we will go through a very important example, in fact a set of examples related to Laplace transform. Here is a small recap that Laplace transform for any given function f of t is computed as this integral f of t multiplied by e to the minus st, and this integral is solved by putting these limits from 0 to infinity. Right, so the example that we are going to solve in this lecture is f of t when it is put equal to t for t greater than or equal to 0, and you know that this transform is defined for t greater than or equal to 0. Right, so Laplace transform of t is we plug the value of t here instead of f of t, because f of t is given to be t, and rest of the things they remain the same. And we start solving integration by parts, and you know integration by parts is applied by first identifying the first function and the second function, and the first function is integrated, the second function t in this case is written as such, minus the first function integrated is written the same as it was written here, and the second function is differentiated, and the whole is put in an integral. And for this part, the first part, we apply limits from 0 to infinity, and this thing becomes 0 because it is the minus infinity is 0, and the second limit becomes 0. When you put 0 here, this e to the minus 0 multiplied by 0 becomes 0. Right, so this whole stuff becomes 0, the first term, and this minus when multiplied by this minus becomes plus e to the minus st. E to the minus st integrated gives us minus 1, and minus 1 over s times e to the minus st 0 to infinity. This gives minus 1 times minus is 1 over s squared. Right, so Laplace transform of t is 1 over s squared. Before this we have studied that Laplace transform of a constant k is k over s, and Laplace transform of 1 is 1 over s. So the first equation for today is the Laplace transform of t is 1 over s squared. We'll keep it for further use, and we have named it equation number 1 here. Right, the next is computing Laplace transform for t squared. We will in the same way put t squared instead of t, and then we apply integration by parts, more or less the same thing, except we have a 2t here because t squared when differentiated becomes 2t, and this 2 comes out of the integral because of the function of t, and we are left with t e to the minus st here. It's very interesting. T e to the minus st integrated from 0 to infinity is actually Laplace of t, because Laplace of t is t e to the minus st integrated from 0 to infinity with respect to t. So if we get a Laplace transform of t, and Laplace transform of t is equation number 1. It's 1 over s squared. So replace this with 1 over s squared, so it becomes 2 over s cubed. So equation number 2, we'll use that equation at the end. We'll use this equation at the end of this lecture. Right, and then f of t is t cube for t greater than or equal to 0, and we solve in the same way, except we have 3t squared here because t cube when differentiated becomes 3t squared, and putting limits we reach here t squared e to the minus st. T squared to the minus st is Laplace transform of t squared. This is Laplace transform of t squared. This one, t squared to the minus st integrated from 0 to infinity. So we plug this value here, Laplace transform of t squared, Laplace transform of t squared, and it becomes 3 times 2, 6 over s to the 4th. So now we come to the last part of this lecture. In equation number 1 we studied Laplace transform of t is 1 over s squared. In equation number 2 we derived Laplace transform of t squared is 2 over s cube, which can also be written as 2 factorial of 2 divided by s cube, and it can also be written as factorial of 1 divided by s squared, and t cube is 6 over s to the 4, which can also be written as 3 factorial over s to the 4. So in general, t to the n is n factorial over s to the n plus 1. For example, t to the 4 would be 4 factorial over s to the 4 plus 1, s to the 5, and t to the 6, Laplace transform of t to the 6 would be 6 factorial over s to the 7. And in general, Laplace transform of t to the n is n factorial over s to the n plus 1. Right, that's all for this lecture. We'll keep on studying more about Laplace transforms in our next lectures. Thank you.